in order to do number 1 here, I don't know what 14 times 4 is off the top of my head. However, if you don't have it, you can still figure it out. Now, first of all, it's a positive 14 times a negative 4. What's a positive times a negative?
Negative.
Negative, absolutely. So we know it's going to be a negative number. So putting that negative down, I've now taken care of the positives and negatives. But rather than dealing with trying to multiply 14 by something, I'm going to break the 14 up into a couple pieces. I always try to break the big number up. The 14 is the same as 2 times 7. So I'm going to be doing 2 times 7 times 4. Now, there are actually other ways you could break it up in order to be able to figure it out. This is just one example. All right, so I'm now going to go ahead and multiply the biggest numbers out of that. That means I'm going to multiply the 7 times the 4 here. So what is 7 times 4? 28. Now, by the way, a little side note here. If you're looking at that 7 times 4 and being like, I don't remember what 7 times 4 is, you could always do it as 7 times 2, 14 times 2, which gives you the 28. So that's a way that you could know that. All right. Now we need to do the negative 2 times 28. And of course we know the negative times the positive is a negative. And 2 times 28, well, 2 times 20 is 40. 2 times 8 is 16. And so if you do 40 plus 16, it gives you 56. So 2 times 28 is 56. Now we go into the 5 times the 22. First of all, a negative times a negative is a positive. So we know this is a positive number. Now the 5, I definitely cannot break that up into any pieces. But the 22 I can. The 22 is 11 times 2. Now looking at those numbers, I'm again going to try to multiply the biggest ones together first, because I do know what 5 times 11 is. That's 55. And I can do 55 times 2. That's fairly straightforward, I hope. 55 times 2 is 110. And so notice it's just a matter of knowing how do we use these numbers. And as you build up that number sense, you'll be amazed at how many things it starts impacting and affecting. All right, last one. Negative 60 times 8. A negative times a positive is a negative. So we're going to get a negative here. And I'm going to break the 60 up into 6 times 10. Because if 10 goes into it, it's actually really easy to multiply a number by 10 later. So now I'm going to do 6 times 8. Now hopefully you know what it is off the top of your head. But again, if not, you can still break it down further. Like 6 times 8?
48.
Well, that's the same as 6 times 4 times 2, for instance. And 6 times 4 is 24. And 24 times 2. And that's how we can know that it's 48. And again, it's a matter of the more you know your multiplication table, the easier this stuff gets. But of course, it doesn't mean that if you don't have it all down perfectly, that you're all of a sudden stuck. There's always a way, and that's part of what I'm wanting you to see, is that there's still a way to figure these out. All right, and then if I'm going to do negative 10 times 48, that's going to give me a negative 480. Because anytime you multiply by 10, all you're doing is just adding a 0 onto the end of the number. So 48 times 10 is 480. We're next going to be taking a look at solving equations. This is like what we were first touching on yesterday. So what I'd like you to do is write down both of these equations, go ahead and solve them each out for x, and then we'll go through them together after you've done that. With the first one, in order to solve it, the very first thing we want to do is we want to get rid of the 4, because we always get rid of addition or subtraction first. Now notice the 4 here is positive. The negative, the minus, goes with the x, because it goes with whatever follows it. So if I'm going to move the 4 out of there, that means I got to subtract the 4 from both sides. But then notice it leaves me with a negative x, because I got rid of the 4, leaving the minus x behind. So we got the negative x equals negative 7, then go from there. So in order to get rid of the negative that's in front of the x, remember that's the same thing as negative 1 times x equals the negative 7. So if I'm going to get rid of that negative, that means dividing both sides by the negative 1. And so then we got x equals a positive 7 there. All right, now on to the second problem. The very first thing I want to do is I want to get rid of addition and subtraction. Now in this particular one, The minus 7, though, it's trapped inside the absolute value, so I cannot do anything with it yet. But I can get rid of this minus 6. So I'm going to add 6 to both sides. Once we've added 6 to both sides, we've got negative 2 equals the negative absolute value x minus 7. The negative is outside of the absolute value, so I still have to get rid of it before I can deal with the absolute value. Again, that's like negative 1 times it, so I'm going to divide by the negative 1. So I got 2 equals the absolute value of x minus 1. Now, how do we get rid of absolute value? So, if this x minus 7 equals 2, the absolute value of 2 will give me the 2 here. But, if that x minus 7 equals negative 2, the absolute value of that will also give me a positive 2. So, I set it up as x minus 7 equals 2 and x minus 7 equals negative 2. And then we solve that out from there, get rid of the 7 by adding it to both sides of both equations. You should find here that x equals 9 and 5. Alright, so you start by writing this equation down above your first graphing grid. And then we're going to take a look at how to graph this. Now, in the past, when we saw problems that look like this, the plus 6 hanging on the end would tell us that the graph was moved up 6. The fact that there's a negative here does not change that. So it is still going to start up 6. So put your first point just up 6. And as you're doing that, notice there's nothing added or subtracted directly to the x. That's why it's not been moved over, only up. All right, now from here, normally from this point, if it was x squared, we'd go over 1, up 1, and then we go over 2 and up 4, and so on. But we are not going to do that here. This is what the negative does. The negative is actually going to tell us to flip it upside down. So instead of going up, we go down. So for instance, instead of over 1, up 1, we go over 1, down 1. Plot those points. And then after we would normally go over 1, up 1, we go over 2 and up how far? 4. So in this case, that means over 2 and down 4. Okay, so after that, what if I go over 3? How far down should I go? 9. Because 3 squared is 9, and this is an x squared equation. All right, it looks pretty close. Let's actually check and see, would the next point fit? If we go over 4, how far down should we go? 16, because 4 squared is 16. Can we actually go down 16 from our starting point? Yes. Barely, because it just hit the bottom of the graphing grid there. It's down at negative 10. But yes, it does fit down there. Now, since that's at the edge of the graph, definitely we're not going to fit anything past that. So go ahead and draw your curve that goes through those points, and then that graph is done. All right, next up, please write this equation above your second graphing grid. And first up, we find out where that first point goes. So first up, the minus 3. Which way does the minus 3 move our graph?
Right.
Yeah, it moves it to the right, absolutely. Now, if you are a little rusty on why do we know it's to the right, because if it's in with the x like this, that means it's moving it in the x direction. And anytime we move in the x direction, minus goes right, plus would go left. So we're going to go right 3, and what's the plus 2 do?
Up 2.
The plus 2, yep, is going to be up 2, because that 2 is just hanging on the end. It's not in with the x. So put your first point there, right 3, up 2. Now, this is an absolute value equation. What's the shape of the absolute value graph?
V.
Yeah, it's that V shape. So I can be expecting that normally it would be looking like this. But of course, it's not going to look like that, right? It gets flipped. So instead of opening upward, this one's going to be opening downward. Go ahead and plot those points then. And so for those first points, for instance, notice we go over 1 and down 1 instead of over 1 and up 1. All right, and then the rest of our points, we keep going over 1, down 1 because it is the straight V shape. Draw the lines that go through there, and then you have your graph. All right, last one we're going to be doing together here today. Please write down this equation. I'll be doing a square root graph this time. And then once you have it written down, plot your first point And then hold tight there so we can make sure that part's right, because of course if the first point's off, everything else is going to go off. All right, so let's see where that first point goes. The -1 that is inside with the x, which way does that move it?
Right.
It does move it to the right. Yes, since it's in with x, we know it's left or right, and minus goes right, plus would have gone left. Now the +6 hanging on the end here. The +6 is going to move it which way?
Up, but you do
Up, absolutely, because it's hanging on the end. That means up or down, and plus means up. So there's your first point. Right 1, up 6. Now we need to start plotting points for this graph. Now this is a square root graph. Normally then, my graph would look something like this. I can draw that better. Looks kind of like that generally, but of course we're going to have to be more specific than that. And what's going to change about this graph? The minus means, yeah, instead of going up and to the right, we are going to be going down and to the right. So our final graph is going to be looking something like this. It's going to be going down and to the right. But we just need to make sure we have all those points in the right spots. So go ahead and plot those points, see how you remember the square root pattern, and then we'll go through it here in a few moments. So in order to follow that pattern, see exactly where the points go, basically however far I go over, I'm taking the square root of that number. So for instance, if I go over 1, what's the square root of 1?
1.
So that means over 1, down 1. Now, from there, I don't want to go over 2 because I don't know the square root of 2. I also don't want to go over 3 because I don't know the square root of 3,
4.
but I do know the square root of 4.
2.
The square root of 4, yes, is 2. So that tells me I'm going to go over 4, down 2, and plot a point there. All right, I just went over 4. How far over should I go next?
3.
Next up, it's going to be over 9, yes, because the square root of 9 is...
3.
So over 9, down 3. We've hit the edge of the graphing grid, so we're definitely not going to be able to fit any more points on. Go ahead and draw the curve that goes through it from there, and you have your graph. That is complete.